Recorded.
So I know that Brendan has to leave early, so we could probably just get started now and then kind of go back and do new folk introductions after he's done, because I just want to make sure he can get through what he wants to before he has to leave.
Awesome, thanks so much. Okay, so I'd like to just share a little bit about what we've been doing in the SPDX community related to something called the build profile, which is kind of like trying to express some of the things that we are expressing here in SLSA, as well as looking at it from a perspective of reproducible builds as well. So I know it's like SBOM is like a very overloaded term, but SPDX is going into this model in SPDX 3.0 where it's talking about having different profiles and different use cases when talking about like different, you're using SPDX for build, you're using SPDX for defects, you're using SPDX for artificial intelligence use cases. So we're treating kind of all those things differently, and you kind of want a different SPDX document. Whether you call it SBOM or not SBOM, there's some nuance in that. But I think just to make it clear, we are not the work here is not about like saying that okay, this build information should go into SBOMs as we know it, but this is kind of a particular use case that can be expressed within SPDX. So I think the main thing I want to do is to share the group that this effort is going on. I want to share just a little bit on what it looks like, and I think what we're looking at is to be able to express SLSA type provenance within SPDX documents, and also to kind of like start a conversation with like making sure that we are aware of the different work that we're doing and making sure that it's aligned. So I'm gonna share my screen really quickly just to show some of the work that's going on there. So folks from Reproducible Builds are part of this effort as well. But basically it looks something like that, where we want to express some like SPDX elements to say, what was part of this build, how was the build done, who was it initiated by, where was it being built, and so on. And essentially, basically, like being able to express things from reproducible builds, as well as to express SLSA type provenance files or metadata, so that they can be used within an SPDX context for compliance and for certain use cases. So we meet every Monday, and so I think we want to kind of start at least a mode of communication that we can share a bit of what we're doing, making sure that we're aligned, making sure that we are able to express like all the things that SLSA wants to express as well. So it looks like questions.
Yeah, I had one, which is what is driving the value of this and how is it different from the original in toto design?
Yeah, so we are not looking to generate like the provenance documents. I think it's more on SPDX as a whole is trying to encapsulate, what are the things that within this data model that we may need to use. So in the sense of like creating SBOMs and things like that, sometimes it's useful to have the build information. So this goes into any time someone wants to make a statement for compliance in terms of a build that's happening, or artificial intelligence models that they're using. They want to be able to express it within SPDX. So it's to be able to kind of integrate additional metadata within the SPDX model so that they can do more things with SPDX.
I just want to highlight one real use case there, right? Is for example, can you hear me?
Yeah,
Okay.
hear you.
Yeah, so one of the real use cases, right, is I remember a while back, right, there were certain open SSL vulnerabilities that were only applicable if the software was compiled with certain flags or compiled with certain additional features. And a lot of that information today really isn't captured in many of the SBOMs. And so I know that's one of the reasons why this could be, that's one of the use cases for it.
Yeah, but isn't that covered by git bomb? And we actually put it in the debug symbols for Windows compilers. Right? We put all that information there already for this reason. So I'm trying to figure out where the intersections of all the other pre-existing technologies sit with this and what's the super valuable value here. And I'm not detracting from the discussion of SLSA and all the rest of it. I'm just trying to figure out, huge JSON documents for monolithic builds seems to be problematic.
Yeah, so that there is definitely going to be overlap. I think the use case more of here is kind of like within the SPDX ecosystem of what people use for compliance that needs to be expressed. I think we see git bomb as a way to augment the information that we're getting. But I think in the end, there is an ask for these documents to be in a data model that's interchangeable, and SPDX provides that. Does that help?
I was going to let Mark, has his hand up.
Yeah, so would this replace the SLSA provenance predicate that we have now?
No, I don't think it would. Well, it depends where you want to go with it, right? Because I think it could be expressed in that way, but like I think there are other use cases that it tries to aim at as well. So I don't know whether it would be a replacement rather than a possible representation of it. So I imagine that maybe there would be more than one document that you could use to produce create SLSA compliance. So whether it's a SLSA provenance document, it could be the SPDX document, and hoping that that could also be a way to kind of like expand the adoption. We are not looking to, at least as a community, we've discussed this, and we are not aiming to kind of replace the provenance spec. In fact, we have conversations, we've had conversations of saying that the SPDX document should reference the SLSA provenance spec and so on. So it could be like, I'm going to take this SLSA provenance document, and I'm going to pass it and express it in SPDX, and also have a reference to say that this is how I generated this SPDX document.
Yeah, because it seems like if the information is very similar, I don't know how others feel, so just speaking for myself, it seems desirable, like if SPDX can represent everything we need and it has the properties we want in terms of being unambiguous and like not, hard to mess up, then like having one specification instead of two seems desirable to me, of like deprecating the SLSA predicate and just having SPDX. Sounds nice. And if we think long-term, we do actually want to have these two ways to represent this information, I think we should come up with a clear story of when to use one and when to use the other. Because right now, I think it's really confusing. So
I agree with that statement. It gets really confusing unless we're really crisp.
So would the best way to make progress here to joining the SBOM meeting the best way? Is it to start some sort of thread? What is a good way to kind of continue this conversation?
I think joining the build profiles meeting, at least within we are gonna get a model down within the next 2 weeks. So I think thereafter we're gonna probably be in a better position to talk about what we want to do with this. So just to update, the build profile stuff is aiming to be part of SPDX 3.0 draft. That's going to be published around end August, September timeframe.
So do you have a link to those dedicated meetings, or do we have to go hunt for them?
Let me put in a link. Main tabs. Yeah, I'll copy all these links in the notes as well, so it's going to be easier to find. I didn't manage to catch up on all the chat, but any questions that okay. Doesn't look like there were any more questions, unless I missed one. But I'd be happy to kind of chat about this offline as well, if you want to chat.
Thanks, Brandon. So we usually spend a few minutes for anyone who's new to the meetings to just quickly say hi and where they're from. So if anyone is new and would like to quickly say hi, love to hear from you.
Hi, I'm Mike Scavetta from Microsoft. I lead an open source security team and co-lead the Alpha Omega project within OpenSSF.
Hey, I'm Jeremy. I'm also from Microsoft. I'm also SIG release tech lead for Kubernetes. So here with both hats on.
I'll reintroduce myself. My name is Roy Williams. I'm also from Microsoft. I missed the last couple of meetings, but I plan to be more diligent. So we'll see how it goes.
I'm Jay White from Microsoft. Sorry, I don't have my camera on this time. I'm sitting here with what looks like a gurney on. More explanations later. Anyway, I'm on the open source strategy ecosystem team, and here for all the fun.
Hey, I'm Simon. I'm from IBM. I'm contributor to the Tecton project and early consult with Kim on SLSA. I help run the IBM Cloud CD pipeline service. So we're very interested in SLSA.
Hi, I am Alvaro Figueroa, also from Microsoft, and I'm also the maintainer for Slackware and RISC-V. Hi, everybody.
I'm Adam Shamblin from VMware Tanzu on their Artifact Integrity project.
Corey McDonald from AWS. I'm a senior solutions architect.
Hi, David Edelson from IBM Open Source Ecosystem and also a leader of the GCC Steering Committee.
Hi, my name is Ding. I'm interested in SLSA. Nice to meet you all.
All right. Does anyone else? Thanks so many. Great to see so many new faces. It's exciting to have you here. As a reminder, we usually keep, if you're able, in the meeting notes, we keep track of attendance, so if you could join there. And there's a link at the top of the Google group to join to be able to have right access. So thanks everyone for joining, and really looking forward to working with you all. I know I've personally in other meetings met some of you. So but it's great to have everyone at the big community meeting. Next topic is, as we discussed in the last meeting, we'll be forming work streams, although there's a question about the naming. We didn't use the term working group because OpenSSF has working groups, and so we didn't want working groups within working groups. We sent out a scheduling survey and we had responses. There's the link in there. There's no particular obvious good times for all of these meetings, but what I just earlier today, I think times that work are for the specification work stream meeting on Mondays at noon Eastern. It seems like people are all over. There's West Coast and Europe, West Coast US and Europe, so there's no particular good time, but noon is like an okay-ish time. Tooling, most people can make Fridays at 10 a.m. Eastern, and for positioning, Tuesdays at 2 p.m. Eastern seems to work. So that's what I suggest, unless there's any objections, that we set up the initial meetings. We have I suggest that the best way to communicate this further is on the Slack channel. We will document this on the website too. But I think for like the initial meetings, we could use this dedicated Slack channels to coordinate and set up like meeting rooms, video chats, etc. And add it to the public OpenSSF calendar. But I just wanted to share that that's happened too. So sorry for the delay in that. I had taken off on Tuesday and was busy yesterday, so I didn't get a chance to do that till today. So that's it. And I think for further things, we'll do it through Slack. Oh yes, so this meeting here, the bi-weekly community meeting, we'll continue to hold that. The plan is that each work stream can have a brief update in the beginning, and then we could talk about kind of more general issues. There's a question from Corey about joining Slack. There's a way to join Slack. We will also send out, there's a email alias too per working group. So if you sign up for one or the other, we'll send any sort of announcements about joining on both. So that way, in case some people prefer Slack or some people don't want to use Slack, for example. And that's how we'll do the initial communications. Anything else on that topic? All right. I think Sean was next on attestation discovery and dependency graph walking.
Sure. So as per the specs requirements, attestations are at source level 4 supposed to be dependency complete, and that includes the dependency, all the dependencies that form part of the build graph. So the transient dependencies at build time as well. But I'm wondering, the attestation format itself contains in the materials section links to the other artifacts that were part of that build, but not to the attestations for them. And given that most people's entry point, and the reason that they will want the SLSA attestations is because they're downloading the artifacts. So what they will have primarily is a link to the artifacts. And I wondered whether anybody had done any work and what approaches they'd taken to, given a reference to an artifact, finding the attestations for it. And even though we're only talking here about the build dependencies being part of the dependencies complete, that's not the same as the runtime closure of the artifacts that you're shipping. So it would also be interesting to be able to find the attestations for the other runtime dependencies that your artifact has. And I wondered whether there was any work on that people have done on being able to discover just basically being able to, given an artifact or a reference to an artifact, being able to find the attestation for it. So Michael's got his hand up.
Yeah, so this is something I've worked on in the past, and I know I demoed it here a while back, sort of the, what do they call it, SCQ tool that sort of goes out and sort of recursively iterates through SLSA attestations. And so one of the things there is right now making a bit of an assumption that those attestations are being stored in Recore. Obviously, that's not going to work for everybody. But one of the things, and it's on the agenda, but the thing I was going to talk about a little later was a few of us are starting to poke around with this idea of sort of, you know, an API for discovering these things. So the idea there being, right, for policy consumption purposes, it's usually valuable to have it associated with the package. But when it comes to sort of more generic like discovery of like, hey, how do I discover attestations that are associated there, whether the attestation is purely SLSA or it could be, you know, security scan attestation, something like that, you still want to have something there. And so there is work being done there right now. The easiest today, if you want to do it today, is to use something like Recore and essentially recursively look up the hash based on what you're seeing in the materials in Recore, and then say, great, is there an attestation associated with it? If so, then complete out the graph there.
Okay, I mean, so when I looked at Recore, I saw that, yeah, basically given you could certainly search the log for the attestations, but there wasn't a way that I could see easily to find it by the artifact or a reference to the artifact itself. But if you can do that via the hash, that's an interesting.
Yes. Yeah, you can do that via the hash today,
Okay.
at least.
That's interesting. I think it might be more interesting to have something a little more explicit. But yeah, that's an interesting way forward. Mark, you had your hand up first.
Yeah, so to clarify your question, one thing is actually finding the attestation and getting it. But did you also mention that, like at build time, if you input attestations for particular artifacts, recording that in the provenance, is that what you're saying, or is that not?
No, not really. It's just in terms of being able to, once you've got a complete software stack, is being able to recursively find all of the build and runtime dependencies for that runtime stack and finding the attestations for them.
Yeah, I think this is one of the problems that I'd like the tooling working group to specifically work on, is like how to do that in the model. One recommendation I have, which I've mentioned previously, is looking up by pure hash has a problem, because if you have build artifacts that are like, you might get hotspots. For example, the empty file is probably generated by lots and lots and lots and lots and lots of different builds. So even if it's not malicious, it might just be the case that you just get many results. So storage and retrieval are both hotspots for that. And so you might want to look up, so not even just hotspots for performance, but also for usability of, like, if you don't have an attestation that satisfies it, you might, there's no good way to present a good error message to users, because you say, I looked up 4 million attestations, none of them passed the policy, I don't know what to do. Versus like, your policy said you need X, I found Y, you know, what's the problem? One way to help with that might be to include like some sort of package identifier or URI or something like that. Somehow in the lookup, I think details TBD on exactly how that would work. So it's just something to consider.
Okay, Roy, you have your hand up.
When we were thinking through this, you know, the hash of the package is one thing, but we were thinking of using the SBOM itself, the identity in the SBOMs to walk through and use the SBOM IDs as a way to find the attestations and build up the rest of the graph. You get into this interesting question, though, when you hit the OS boundary as to whether that's something you want to include or whether that's where you stop. And when it gets into reproducible builds, it's the same discussion: is do you stop at a specific layer and say, hey, from there on, we consider it stable. I think for doing deeper grain analysis and getting around the issues that Mark was referring to, going through the SBOM ID or the SBOM itself would give you the right information instead of doing a lot of false walks through the system.
Yeah, I think that's it. That's another interesting point, is where you do graph termination. The operating system is one point where you could do it, but there are other things where, for example, proprietary tooling, where you could potentially give a digital signature that you couldn't verify because you don't have a license to actually ship the artifact that you're signing to whoever's actually validating it. So yeah, I mean, that's another point about graph walking, is where do you terminate and how do you terminate that graph in such a way that it makes sense that you are actually talking about terminal nodes at that point.
In our case, we have the additional benefit of we produce the compiler, so the compilers the OS uses are not public at the time we use them, and then the changes get rolled into an official release later on. So yes, that is an interesting sort of discussion, and love to have discussions on the right way we want to solve some of these things.
Okay, well, that's given me something to work with, and yeah, I'm happy to kind of take this out and make it a discussion in the tooling working group. Thanks.
The resonating thing, just one last thing, is that a lot of the the Linux Foundation and a lot of and Microsoft in particular have stated for every package we're producing an SBOM. And the question is, do we just inherit that as part of the expected artifacts we use to build the rest of the system on?
Yeah, good questions. Okay.
Yeah. Oh, I was just going to say, I mean, to be clear, this is purely proof of concept code.
Mm-hmm.
But if folks did want to poke around with it, where's this? I did have, where's this thing? I do have that, which is just purely sort of like, hey, could you recursively, assuming you did have SLSA attestations that referred to other things, could you recursively traverse through recore?
Yeah, that's useful. Thank you. Okay, who's next?
I think we have an entry. I don't know the specific person, but the SUSE team talking about their compliance work.
Yeah. Yeah. So, is it okay if I share some slides, perhaps, then just go through them? Okay. Just a second. Is it? Yeah. So basically, what I would like to talk about how we started looking at SLSA at SUSE and started to work with that and worked on the compliance or working towards the compliance towards the SLSA 0.1 standard. So SUSE, you might be aware, is a Linux operating system vendor. We take a lot of community code. We review the code. We select the packages that we ship in our products. Then we build them from source code to binaries, put them into our testing pipelines, sign them, and put them on various content delivery networks in either RPM form, FTP trees, ISO images, containers, and so on. This kind of very simplistic diagram visualizes where we have the control of. So we don't have control of the community code, we take that in, but we have control over the code review, package selection, building, and so on. So we have been doing various certifications on security side, like common criteria in the past, and we became aware of SLSA and brought this idea to look at SLSA compliance to our management. Our management liked the idea and said, go ahead. And so we went and did the gap analysis, what SLSA is composed of, how it fits our what we have already, and what do we need to change. And so we went ahead and did that. and we found that what we are doing as building, as source code management building, is already meeting quite a large part of the SLSA framework that it is standing now. And we decided to refine the rest of the pieces or art pieces that were missing. For instance, provenance was missing. So a bit more details about that. So the entirely building of our source code to binaries, including turning it into RPMs, turning RPMs into images and FTP trees and whatnot, is done by our open build service. So the open build service is a SUSE developed in-house build service solution that manages source code, it builds binaries up to the point of signing and publishing. We've been using that like forever. So as I joined 20 years ago, it was already there. It's now the second, third generation. It's also continuously developed. Source code is stored inside of the build service with full history, with associated users who did what, with possibility to manage diffs and so on. Sadly, it's not in a JIT format, which is today's standard way of doing that, but in some form of SVN-like own handcrafted storage. So this is something that we are also planning to see if we can replace it by external JIT storage, for instance. Yeah, so it does the source code management. Source code management we have internally, we separate between projects and packages. Packages just one source code package like glibc, like Vim. Projects encapsulate things like /15 as before or OpenSUSE Factory. And the build service models access management on top of that, based on user, on groups, so that access protection exists in that side. The sources are stored as packages with changelog revisions, and we have tooling around it that verifies incoming GPG signatures, for instance. So this is one challenge, how to get source code into the system when trusting whoever is has provided it is really the maintainer. So that is, however, for us a bit outside of the SLSA scope, but it's something that we are also looking at of how this can be improved, like with more GPG, SIG store, whatever methods. Internally in the build service, source code moves between projects. So we model the actually release process on top of that between developer homes, staging projects, final build projects, or release projects. These kind of moves happens only after either human or automation reviews or multiple stages of that. So we can mirror all kind of release process on top of that. For instance, SUSE Linux Enterprise development is a two-stage thing. We have developer homes, our package maintainers. They do their test builds, they do their check-ins there, see if it has built, and then submit it or for request for copying to the build project. And this request is reviewed by source review teams, legal team, legal automation, release automation, and whatever you can envision. The build project builds the sources. So what is submitted is not binaries, but sources. It rebuilds everything, includes sub-staging projects for QA to do the continuous integration parts. And in the end, these build projects can be frozen or release binaries into release projects to either create GA builds, containers, and so on. For Factory, our open source project, we have a free stage or free project setup. Like the community developer has its own project, he can work on that. He submits to a so-called development project, so an intermediate project where more senior community members review the changes, look if they fit the style that is required, and then forward it to our main factory build project, where we again have the building of binaries, staging, and publishing to our users. So the build service is kind of flexible. We can define that in that, and
mirror the access restrictions in whatever way is fit. The user management is done via an external LDAP-based IDP solution. We here at SUSE use Univention Corporate Server. That's a Debian-based commercial product that is run on-premise, so that we have still full control over the user management and the build service. So the build service is also hosted in the SUSE data center. The group management is not in LDAP, it's managed in the build service itself. Excuse me. So building binaries, the build service has the set of workers. Basically, every one of them is a specific machine that spins up worker instances, worker KVM instances, builds the package and discards the KVM instance afterwards. So it's isolated, ephemeral, also scripted build, so there's no human interaction. So that a source check-in triggers the internal scheduling, and the internal scheduler distributes the builds to these workers, and yeah, including, of course, automatic dependency resolution. Binaries are not leaving the build service or not getting stored outside of the build service, but also the intermediate binaries are stored within the build service. In the end, of course, they leave it as the deliveries, but the normal user has no way to inject binaries. Of course, with weird RPM hacks, that would be possible, but usually only sources are imported, except for bootstrapping purposes. Signing is integrated, so there's less of a topic for SLSA, but we have an internal signing server that does GPG signing, UEFI secure boot signing, or container signing. And in the end, no binary leaves this build service unsigned. No FTP tree, no CD image leaves it unsigned. So we looked at SLSA. How does it fit the build service? So for the four big pillars: source management, binary builds, build provenance, administration, and went over them and tried to do a gap analysis with the goal of really achieving or going towards the level 4 as it is currently. So the source code management, as far as we see, it meets all the requirements. The authentication of users, there we saw that the strong authentication was not, so we currently had just password authentication, so we complemented that down by multi-factor authentication, so that the simple password stealing is no longer possible. But otherwise, we saw that what we do as a source code management system meets SLSA standards. So we didn't really look further at the source code management. The binary building, we've been over the years working on this already. So what we have with these standalone KVM workers that automatically pull their scripts, that automatically set up change rules, build and discard them. We also meet these kind of things like the stored artifacts only coming from the build service itself. Ephemeral, scripted, hermetic, so there is really no network access incoming or outgoing to these workers. The builds can be redone, and it's also to some form reproducible. As we are building RPMs, with reproducible, we face the challenge of timestamps and signature nonces occasionally. So we are still struggling to get a full bit identical RPM reproducible build. So this is something where we still have a gap at this time, but it's at least content we are working, or we have a high percentage of our build is already, the content of the RPMs is binary reproducible. There's usually no human or outside interaction on these builds. So, and it's all managed in our data center, not on any kind of development workstations. Provenance, as we went to implement it, we saw that provenance we have not been doing yet. So we captured build environments internally, but this was in an internal feature. So our build ops team implemented this in toto attestation format or provenance format, describing what binary RPMs are used for the change for this KVM rooted build, what the configs are, what the sources are. And we store the artifacts on the outside server sources.suse.com and deliver this in total JSON files, this attestation files in parallel to the RPMs that we deliver. With, of course, the goal to reproduce the build by third parties. We have meanwhile also implemented that our build tooling can use our in total attestation and reproduce the build externally. So that's, but it's not kind of in a standard, not sure whatever standardization is for the in total to reproduce that. So this was a big part that we needed to implement and where we spent quite some effort on that. It's probably not fully finished, especially the signing part was a bit tricky. Yeah, we started delivering that around 2 months ago. Administration, so the whole build service, so that was the fourth pillar. The whole system is usually deployed with solid states and on VM cluster that can be spun up with either solid deployments and or similar methods. There are still some admins, of course, that can do changes to the system, but we've looked at these other requirements that this should be very limited and two-person reviewed. We're trying to do it. I mean, of course, the super user can do a lot of things. It's kind of hard to enforce these kind of super user two-person review restrictions, but we strove to implement those. So the whole thing is deployed and managed also DevOps style. So challenges that we faced, provenance challenges. Currently provenance for RPM builds kind of easy. We put the JSON file beside the RPM. Still looking how to do container provenance and where to publish the provenance files in the end, beside in the OCI registry or in the record log or wherever. We also saw that, especially if you look at OpenSUSE Factory, that is a always rolling release that rebuilds occasionally larger sets of packages. How do we keep the provenance for everything, including all the RPMs that a specific RPM was built with, because that will easily explode in storage requirements. So, so that is a bit still of a challenge, and that's why, for instance, for OpenSUSE Factory, we have not inherited because we don't have that much storage available. It's would just be too big. And occasionally we do some weird bootstrapping things. So that's how to do the provenance for the weird bootstrapping. So that's also an open question that we are facing. So yeah, and one challenge that I forgot is that we still had a bit high or a lot of write privileges for release managements that we reduced to the super user group, and we had to change a lot of processes, or we had to adjust the processes to that only the super user team in the end has the final arbiter rights, and everything else is at least two-person reviewed. So yeah, so that was the brief recap of our implementation towards SLSA. Still looking at that, and I'm happy to take questions. Roy has his hand up as first seated. Stop sharing.
Thanks. I had actually 3 questions. One, do you use any build caching layer, and does that stay within your build cluster?
So the workers have a local caching directory for RPMs. So they store just for building, they store the RPMs that they fetch for building, but it's on one hand verified, checksummed, and also discarded if disk space runs out or if the worker is newly deployed.
Okay, and the second one is, I think you run into the same questions we had of what do you do for external third-party tools like GCC and Clang? Who's doing the attestation that they're protected to begin with?
You mean for importing sources, or
well, if you still need something to build your sources to start, like where are you going to get your bootstrap tools from? I think that's an open question for you too, which is where do I get the basic compiler to build the next compiler?
Yeah, I mean, we started this in the middle of our big code stream. So basically assumed what we have as existing, but yes, the bootstrap issue is a topic. Okay. So, and it's a challenge, especially if we would like to say, if we introduce RISC-V as a new architecture in the near future, how do we start? Yeah, how do we keep track that we imported this binary blob or this binary pre-built binary? Similar, perhaps also if we import Rust bootstrap binaries or something like that. So that's an open question. Yeah.
Okay, and the last question, you said you had you turned off network access through the build. Now, is it read and writes or just reads?
Yeah, so the way that this works is that our worker client instance, it fetches all artifacts to the local machine, then spins up a KVM instance, or it basically prepares a very limited set that it can boot out of these packages, then spins up a KVM instance, boots into this minimal instance. And the minimal instance has the RPMs, the sources inside. Then this KVM instance has no network interface. It builds everything through. In the end, writes out a CPIO archive at a specific location in the file system, terminates itself, and the worker node extracts the CPIO for the build results like RPMs, build log files, statistics, and so on. So the actual build doesn't have any network interface available.
So you don't. So that brings up two questions, which is, if you isolated your sign-in service to be on a different cluster or network boundary, you would preclude them reaching out to sign, or you would open a door.
I mean, of course, the worker nodes and the source server, the binary servers, they are in a network. You know, but the build itself is not able to access this network. So the worker node transfers the binaries back to the binary backend. There, the binary backend is taking care of the signatures. So works with a one point-to-point connection with the signing server, signs it and stores the binaries. But build itself is not able to access this network.
The thing I struggle with is trying to write SLSA evidence and claims out during the builds. You're basically in a model where you're going to have to write them to a scratch directory on your build machine, wait for the instance to stop, and then harvest it. And there's that window where if something is already in that isolated box, it's going to give you tampered. So you can't get them out through a different path to say, hey, it's untamperable. Without...
I mean, I think in the design decision, we look at the build service itself at the cluster as not to be tampered with, so that it's not able to be tampered with. Even if it's a multiple machines, we consider this as one unit, as a trusted unit. So, because otherwise it will be a bit of a challenge. That would make it more complicated to really sign this in the build and not be able to trust the intermediate network or something. But so currently we abstracted as we look at our build service cluster as one trusted entity.
Okay, thanks.
You're welcome. More questions? If not, then thank you. If you have questions, drop me an email.
So, quick question: what's your longest build or your largest build? Like, are you running constraints where you need multiple workers to build parts of it, or do you think you're all within one and it's hours worth of build at most?
So, largest build is something like Ceph or Chromium or LibreOffice, probably not, but kernel. And when I'm talking about worker, it's occasionally we have these 64 CPU big fat machines where worker node is assigned like 32 CPUs or 16 CPUs and so much gigabytes of RAM. So there is no secondary, so there is no two machines in play. It's always one machine, but with a lot of CPUs. So it's virtual CPUs in this case. So we had 10, 15 years ago experimented with ice cream, so offloading compile jobs. But we stopped doing that. What we are doing is we do compiler caching, CC cache compiler caching for some packages like Ceph. and store the intermediate CC cache as an artifact also beside the RPMs that were built. Also interested for in total attestation then, yeah, that there is this CC cache. Yeah. It's a channel. It's yet another thing to think about. Yeah, but usually a very big beefy build machine will get you there. Still, Chromium on AMI64 on OpenSUSE builds 18 hours, so it's long. Yeah.
Thank you.
Welcome. Back to Mark.
Thanks so much, Marcus. That was really great and really helpful. I think it's really nice hearing how people use the specification. And also, as we think about the next version of the specification, I think it's really useful to look at this as an example of like how it was used, places where like we did well with the spec and places that we could do better. Like in particular, I thought it was interesting about the comments on the common criteria, or that's the wrong word, the common requirements around like two-party review of the administration. That was something I thought actually was like not very readable, and most people just ignore it, but it's good to hear that that was usable. So I'd like to include that in some form in the next version. I think we only have a few minutes left. I think Michael wanted to have something about artifact fact finder.
It can wait till next time. It's not a big deal. We were just, I think it's tied to what Sean is doing. There's a beginning to be an initiative. Nothing super public right now. It's just a few of us in the community, like Santiago from Purdue, and Brendan Lum from Google, and a few of us have sort of been poking around with some interesting ideas around how do you distribute SLSA provenance and other attestations and metadata artifacts, and how can you start to ask questions of your supply chain based on it. But details can wait till next time.
I think there's one more thing. Asked to review a blog post. It's a pull request, so I think we could discuss that on, if you have any feedback on the pull request. Also, there was. It's probably worth highlighting that there's a pull request out now to change the the contributing guidelines for blog posts. That was a topic that we brought up last week. And so if you have opinions on that, please review. I'll add a link to the meeting notes, but because that's a kind of a governance question, I think it's worth highlighting to the community. Any last topics before we go? Okay, well, thank you, everyone. As always, I appreciate everyone's great contributions and seeing everyone. Have a great week, and I'll see you next time. And we'll send out announcements about the specific work stream meetings.
Thanks, everybody.